Hello everyone. So today we are solving another question of JEE Advanced 2021. This was from the topic of electromagnetism and some little bit of current electricity concepts has been used here. So let's see what's the catch in the question by reading the question first. So they're given a long straight wire which carries current of 2 ampere. There is a semicircular conductive rod which is placed behind the two conductive parallel rails of negligible resistance, and both rails are parallel to the wire. The wire and the rod rail lie in the same plane. Two ends of the rod are at this and this centimeter. At time 0, the rod starts moving with a speed of V equal to 3 meter per second. So a resistance of 1.4 and a capacitor of 5 microfarad has been connected here. So we have to tell what are the current and what is the charge on it. So to solve this, let me first clear one thing, that whenever there is a moving rod in a presence of magnetic field, so it develops a EMF among it. How does it work here? Let's suppose there is a rod, a straight rod, okay? It is moving with some velocity V, and let's suppose this is the direction of magnetic field, okay? So the EMF generated will be BVL, okay? But what will be the direction? It will be nothing but L V cross B, okay? So the V cross B will give us the direction. So if we take here, let's suppose this is our X, Y, and Z axis respectively, okay? Our rod is moving in the X direction. Where is the magnetic field? It is in the minus K. So X comma minus K, what will it give? It will give us the J direction, okay? So it means the positive terminal of our EMF generated will be at the top of this, okay? And the very unique part of this concept is that it doesn't matter whatever is the shape of the rod and whatever is the length of the rod. It only matters what is the vectorial length. If suppose the rod is something like that, okay, if it is like that also, but if its vector length, that is this, if we join two endpoints with a straight line, so only this length matters here, okay? So similarly for there, if we have a semicircular rod, so only this, only its diameter matters, what is the length of it. So what we take a vectorial length, okay? It's something like this, okay? L dot V cross B, okay? Now let's start solving the question, okay? I can clear all this. Yeah. Now, given two rails like this, 1 and 2, and they're given an infinite wire, or the long wire, what we can say. Now the distance given is nothing but, here it is 1 centimeter and here it is 4 centimeter. So let's write the equation of the EMF generated. What is the EMF generated? I have told you earlier, it is nothing but BVL. So what will be B at some point? Let's suppose this is the semicircle. As I told that it doesn't matter whatever we can take shape is of the length of diameter. So we will consider it as a rod of length diameter. Okay. So at some distance R from this infinite wire, let's take a small part of dr and we'll calculate magnetic field at this point. Okay. It will be equal to mu naught I by 2 pi r. For the infinite wire, we know this is the formula for magnetic field, and L is nothing but dr. And what will be the velocity? It is equal to 3 always, as given. I'll show you, 3 meter per second always. Okay. So this is this will be the EMF generated in this small dr part. Okay. DE we can write. Now if we integrate it over the length, so r varies from 1 to 4. Okay. And the net EMF generated will be equal to nothing but 1 by r dr is equal to nothing but ln of r. So mu naught I by 2 pi into 2 pi ln of 4 by minus ln1, which is ln1 is equal to 0. Okay, we can write like this, and we know that ln4 is nothing but 2 ln2. Okay, so we can cancel 2 here, so it will be 3 mu naught I by pi ln2. This is the EMF generated here. So if we know the EMF, then we can write all the equation. Like if suppose this is a battery source, so we can reconstruct the circuit. This is the EMF generated. There is a resistance and there is a capacitor here. Okay, what is the maximum current that it can go? We know that the minimum resistance that a capacitor can offer is equal to 0. So at that time there will be the maximum current when EMF by what is the resistance given? It is nothing but 1.4. So let's see what our EMF. This is equal to EMF. Okay, we can write all the values. 3 into mu naught is nothing but 4 pi into 10 to the power minus 7. So we can write this 4 into 10 to the power minus 7. I is given as 2 ampere and ln2 I think it's mentioned as 0.7. Okay, this is the EMF. So for current, what we have to do, we have to divide it I max. Okay, I max is nothing but we have to divide this EMF with the resistance. Resistance is nothing but 1.4, so 2 into 0.7 will cancel it. So 12 into 10 to the power minus 7, which is equal to 1.2 into 10 to the power minus 6. So let's see which option matches. Yes, option A matches here. And what is the maximum charge on a capacitor? We know that CV is equal to the charge, or you must be remember in this form that C equal to nothing but Q by V. Okay, so Q equal to CV. What is V? V is voltage here or the EMF generated. So Q will be equal to C is given as 5 into microfarad, 5 microfarad. So 5 into 10 to the power minus 6 into this 3 into 12 to 24 into 0.7. That is nothing but think 24/7 is 141. 24 into 0.7 is 16.8 into 10 to the power minus 7. Okay, if we multiply it with this 16,580, so 84, something like that. Yeah, 84 into 10 to the power minus 13, that is 8.4 into 10 to the power minus 12. So our option C also matches, and option D is incorrect, and option B is also incorrect. Let me write the answers, that is A and C. Thank you everyone.